All right, so I want to show you an example of a t-test. And so I have a situation here where we're going to look at SAT verbal scores. So we're wondering, do students who learned English and another language simultaneously score worse on the SAT critical reading exam than the general population of test takers? The mean among all test takers is 501. So a random sample of n equals 100, these would be students who learned English and another language, had a mean of 485 with a standard deviation of 116. So let's think about what it is that we're testing here. We need to write a null and an alternative hypothesis. So the null hypothesis is that there's no difference between the general population and students who learned a second language simultaneously with learning English. So among all test takers, the mean is 501. Now we're wondering if these students who learn a second language score worse, so whether they have a mean that's less than 501. So immediately I want to take note that I'm conducting a left tail test. And that is determined 100% by this statement in the alternative hypothesis. I also want to point out I just wrote an alpha here. That's just a habit that I'm in. Other places you might see a subscript of 1 or a lowercase Latin a. So if you see an H alpha, that's just another way of noting the alternative hypothesis. So this is a left-tailed test. Now in my sample data, there are three things that I want to make note of: the mean, the standard deviation, and the sample size. So in this example, the researcher collected information from 100 students who were learning a second language, and they had a mean SAT critical reading score of 45 with a standard deviation of 116. And so I'm going to use my calculator here, and under the stat menu, scroll over to my test, and this is a t-test, so option number 2, and the assumed mean is 501. The sample mean that I got is 45, the sample standard deviation is 116, and the sample size was 100. And I need to let my calculator know if I'm conducting a two-tailed, left-tailed, or right-tailed test. This is a left-tailed test, so I'm going to leave that middle one highlighted and then hit calculate. And I'll take note of two values that are given to me. T is negative 1.38 and the p-value is 0.085. I'll just leave it at 3 decimal places. Now at some point I need to know what is the level of significance that I'm going to use for this test. And let's say that 5% is an acceptable risk for the type 1 error for this test. So first let's kind of picture what's going on here. I'm conducting a left-tailed test with alpha as 5%. So I'm going to think that there is my cutoff line is going to be where 5% is in the left tail. I want to find this t critical value. And so for that, I'm going to use the inverse t function with 0.05, and my degrees of freedom is 1 less than my sample size. So in this case, I'll use 99. So going back to the distribution menu, I want my inverse t function with 0.05 and 99, and that is negative 1.66. I'm not surprised that it's negative. Anything that's to the left of center would have a t-value that's negative. So there's my line, and now I'm thinking about, well, what happened in my sample data? Well, the t-test value is negative 1.38. So I'm trying to decide if that is over here, which is where I would reject the null hypothesis. So here's the line is negative 1.66. I'm getting a value of negative 1.38, and so my value is actually here's my t-test value, is negative 1.38. So I did not cross the line. So I'm in this region where I have to fail to reject the null hypothesis. Now notice I could also make the same decision if I compare my p-value to alpha. Since alpha was 5%, if the likelihood of my result was less than 5%, I would reject the null hypothesis. But the result I got has a p-value of, like 8.5%. And so that does not meet the standard where I can reject the null hypothesis. So I am going to fail to reject the null hypothesis. So what does that say? Well, if I don't reject this, that means there is insufficient evidence the population mean for students who learn a second language simultaneously with English, the population mean, I should have said what this is, mean SAT, let's see, I think it was a critical reading, I'm just going to say SAT score, for students who learn English, who learn a second language, is less than, we could say less than 501. Another way to say this is, we were testing whether they score worse. So there's insufficient evidence that students who learn a second language score worse on this critical reading exam. All right, so there's just another example, and with a hypothesis test for the mean, and using either the critical value method or the p-value method.